Hi guys, today I'm going to keep it relatively short and we'll just be solving for volumes between two graphs. So this is kind of like a combination of what we did in the first one and the second one. So for this one, what we have is two equations. We have y equals x squared minus x minus 3 and y equals x. And we're trying to find the area between them with squares. Okay, so how would we do this? First, we need to find what these are equal to, like our range. So we know from last time that just means setting them equal to each other. Minusing over the x, left with x squared minus 2x minus 3. And that would give us x plus 1, x minus 3. So we know our range is from -1 to 3. Okay. So now that we have that, we need to find our area with the square. We know area of a square is equal to base squared. And to find the base, we need to put the equations together. So we have our x squared minus x minus 3 and x. Okay, so now we know that this one's going to be on top because if you graph it, it looks like this, and this one's going to look like this. Okay, and we're trying to find this area if you put squares in there. Okay, so now what are we going to do? We're going to take the integral from -1 to 3 of x minus x squared minus x minus 3, which is going to give us the integral of -1 to 3 of negative x squared plus 2x plus 3 dx. Now, that just gives us the base, so we need to square this. And I'm pretty sure in a test, you're never going to be asked to actually solve this out and plug it in. And we already know how to do integrals. It's just going to be long and slow. So you're going to end up getting, if you do this correctly, 512 over 15. And that would be the area if you take it with squares. Okay, so now let's talk if we did it with circles. Just like in the last video, they're all kind of similar. All that you need to remember is that when we put the two equations together, it's -x squared plus 2x plus 3. Okay, so that's our base length. So now if we wanted to do a semicircle, we know the area of a circle is pi r squared. Our radius is going to be equal to that. So we'll take the integral from -1 to 3 pi times radius, which is -x squared plus 2x plus 3 squared, divided by 2 because it's a half circle or semicircle. We can pull this out, and then we're left with just the integral of this, which if you plug into your calculator will equal 64 pi over 15. Now, lastly, let's do what would happen in equilateral triangles because this one's a little bit more complex. And if you didn't watch the last video, I'd recommend you watching it. But basically, what we discussed is with an equilateral triangle, our length is whole distance is going to be -x squared plus 2x plus 3. So in order to find this, because we need the area as base times height, this is the base. Height is going to be √3 times that, because this makes it a 60, 30, 90 triangle. And you're going to end up with √3 over 4 times x squared, -x squared plus 2x plus 3 squared. And that will end up giving you 128 √3 over 15. Guys, this was kind of a short video, but it was basically just combining two things that we learned in the last video, where you want to plug in the values, and the way you solve the base is just by solving for the area here. It's kind of a mesh. So basically, with any time you're trying to solve for a volume, you're trying to find the area where it's going between to get you your integral, and then you're trying to find the area of the bottom. Then you just need to figure out how you would normally find the area of the dimension given, whether it's a square, triangle, circle, or anything like that, and then you plug that into the base. It's pretty straightforward, and if you do a couple practice problems, you'll get it. Thank you for watching this video. If you enjoyed, subscribe.